So section 5.7, our goal today is to understand how to transition from standard form, which you remember as we've been doing for the last couple of days, into vertex form. And that's our goal, is to go from standard form to vertex form, because vertex form is a very fast way to graph. So I've got a couple steps there that we're going to go back to later and talk through it, but I want to walk you through one or two examples, and then we're going to go back to the steps and explain it. So just kind of follow along, and as we go, and you'll kind of pick up the steps slowly, and at the first one, maybe it doesn't make perfect sense. By the time we get to the second or third, it will start to click, as it did last hour with my other students. So let's just come down to here, and I want you to start by subtracting 2 from both sides. So we're going to get y minus 2 equals x squared plus 6x. That's our first step, is to get rid of the number, remember it's called the constant, and move it to the other side. Now, a number of years ago, back when you were in Algebra 1, we did something using a plus blank on one side and a plus blank on the other side. And it was a method that we used, and it was called completing the square. You might remember that plus blank, plus blank. I don't know if you don't. What we're going to do is we're going to add something to one side, and we're going to add the exact same thing to the other side with a purpose to get to vertex form. Now let me tell you what goes in those blanks. 2 simple steps. You cut a number in half, and then you square it. All right? You cut a number in half, then you square it. So, if you would please, what is 6 cut in half? 3. What is 3 squared?
9.
So put a 9 right here. Yeah, remember? Henry, ring a bell a little bit? Now, what did I add to the right side? 9. Now, I'm going to ask the same question 5 times. I'm adding 9 to the right side. Do we all agree? So what must I add to balance it out? 9. It's got to be a balanced equation. All right, we've now done the hardest part. So I have y plus 7 on this side. And on this side, I can now write this in vertex form. Yes, Mr. Bowling?
How did you get 9?
Half of 6 squared. So let me put a little note here. This 9, half of 6, parentheses, squared.
And then was 6 just a random number?
6 comes from the original problem.
Okay, so it comes from 6x.
Mm-hmm.
So you always use
The linear?
Yeah, we always go half of the middle term and we square it. And we're gonna do this a couple times, so you'll kind of get the hang of it.
Is that what we're doing? Is that the hardest part?
Yeah.
So the 6x, so linear, is it always linear, or is it just the
We take half of the linear term and we square it. Now, the next from here down, x times x is x squared, so that goes right here. And the square root of 9 is 3, so that comes from right here. Hold on. Half of x squared, okay, the square root of x squared is x, and the square root of 9 is 3, and the plus sign follows right from the middle. Now, I know this is different. We've done it before, but just follow the pattern, and we'll pick up on it after a time or two. So the number's there. The x comes from the x squared. The 9 becomes a 3 because we're squaring this. 3 squared is 9. Okay? And then the plus comes from the middle on the 6x.
What about the 6x?
Let me kind of go to the side, and I'm going to explain where this comes from. I want to go back to Algebra 1. X plus 3 squared. Now this is back in Algebra 1. That meant x plus 3 times x plus 3. Right? And now we FOIL. X squared, 3x, 3x, and 9. We simplify to get that. So, Now we're going in reverse. And we're saying we need to realize that x squared plus 6x plus 9 really means x plus 3 squared. And so all we're doing here, Karen, is we're doing the reverse, and we're factoring, like we back did in Algebra 1. And I'm just showing you the shortcuts to identify it. Now, we're gonna continue on this one, and then we're gonna do 2 more, and by the time we finish the third problem, you'll get it. So just hang with me. Okay, so right now just copy it down and hang with me, and we'll kind of continue and finish through. We now subtract 7, giving me x plus 3 squared minus 7. That should look very familiar, like vertex form from yesterday. Can anyone identify my vertex? You did this in your homework last night. What's my vertex? Good. -3, -7. Now I have a second question. Who can identify my y-intercept? 0, comma, what?
0.
Look back at the very original problem.
2.
0, comma, 2. And for those of you who didn't see that, that comes all the way from up there.
So what's the vertex? -3.
The vertex is -3. Why did I put -3? I'm not sure. It should have been -7.
Okay.
I'm not sure why I wrote that. Okay, so let's plot these points. -3, -7. And it helps me to draw the axis of symmetry. Now I'm going to plot the green point, 0, 2. And it looks like it's going up. Now let's do our pattern. Yes, Aaron?
I don't know if I missed you saying this. How do you get -3 and not positive?
From yesterday, it's the opposite of that number.
Oh, you still do.
It's always the opposite. Good question. So now let's do our pattern. Our pattern, remember, is over 1, up 1.
Wait, why?
Because that's the pattern of a squared function. Back from here at the beginning when we talked about this on the board. So this pattern was over 1, up 1. Now we do the next pattern. I'll switch colors to red. Over 2, up 4 from the original. Okay? So this point right here, over 2, up 4.
I thought you could only do this like at a certain time.
Yeah, that's what this is that time. And then our third one is green, and I want you to count with me on the green. From the blue dot, we're going over 3 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. And so this fits the pattern, which is over 3 and up 9. So let's reflect that point as well. And so our patterns from our vertex form yesterday that we have here on the board, over 1, up 1, over 2, up 4, over 3, up 9, are being consistent and holding. So now we are just going to zoom in on our parabola, and we're going to try to do a little sketch here. So I'm going to try to sketch, remembering at the bottom, it's supposed to be curved. Coming back up through. And I need you to notice where my arrows are. Do you see how my arrows are really not that much further over? They're just in the next block. So our parabola is not tailing out wildly. It's staying very, very narrow. So our shape of our parabola is still the 1, 1, 2, 4, 3, 9. Same shape as yesterday.
And then we're done.
Yeah. And so our goal here...
Why can we not do the 1, 1, 2, 4 stuff? How do you do it without that?
Well, you would plot points. Much more involved. You would choose the value x equals -2 and plug it in. Choose the value of x equals -1, plug it in. Choose the value of x equals 0, plug it in. And you go from there. So I'm just trying to kind of walk us through how we go there. But our goal, our primary goal, is right here. This is called vertex form. And from vertex form, we can very quickly graph it. All right, let's look at number 2. We're going to do the second one, and then we're going to come back to our instructions at the beginning and kind of do a little review after the second problem. So here we go. Our first step, as you remember, was to get rid of this constant. So we subtract the 4. So we have y minus 4 equals x squared minus 2x. There's our first step. Second step is to put in our plus blanks. So write in your plus blanks. So y minus 4, x squared minus 2x, and I'm going to stick in some different colors here, plus blank in red, and there's our plus blanks. Now let's think through. Remember, we take half of the linear term, which in this case is 2x, and we square it. So what's half of negative 2?
1.
1. Squared? 1. So we're going to add 1. Now, did I really add 1 to this side? You bet. So what do I need to do to balance the equation? Add 1 to this side. All right, so let's simplify now. Y minus 3 equals something squared. Because remember, our goal is vertex form. And Sean, vertex form is, something squared in parentheses.
Yeah.
So to get that something squared, what squared is x squared? X. What squared is 1? 1. And now I'm going to highlight some colors here. This minus sign goes to that minus sign. That's how you know the sign. The sign follows the linear term. Let's go back to example 1. Notice in example 1, I'm going to highlight this in green again. That plus 6x becomes this plus 3. So the sign on the linear term matches the sign in your binomial. Binomial, remember, means 2 terms. So we add 3. Final answer, x minus 1 squared plus 3. All right, time for a little help here. What's my vertex?
1, 3.
1, 3. Okay, somebody else. What's my y-intercept? Good, 0, 4. All right, let's plot those. 1, 3, 0, 4. And I'm going to once again draw that axis of symmetry just because it helps me to see where I'm going. Let's do a little plotting here. Can I reflect that green point fairly easily?
Yeah.
Okay. Is the green point over 1, up 1?
Yeah.
Okay. The reason that is because over here the a value is 1. If that a value is 1, we have this beautiful pattern, 1, 1, 2, 4, 3, 9. So after a 1, 1 pattern, what's our next pattern? 2, 4. So let's go back to our graph. From the vertex, Karen, look at me, trust me, believe. Karen, I know you're fighting me. It's okay. Good. So over 2, up 4. Just that easy. Not yet. Over 2, up 4. Now on this one, we can't do a 3, 9 because it's off the graph. So we're done. So sketch it. And there we go. All right, now let's go back up at the top and slide back up to our steps to follow. And let's kind of go over these together. Step 1, in light blue, it says move the constant to the other side. We've done that twice. Step 2, it says factor out the a coefficient if it exists. Have we had to do that yet? No, we'll do that at the very end. I wrote a problem that lets us do that and practice that. Then take half the b term. That's what you're talking about, that linear term. Half of that. Square it and add it to both sides. Then we rewrite it as a binomial squared. That's that in parentheses piece. And then we bring the constant back over. So those are our steps that we've done these first two problems. So I would encourage you to kind of refer back to those steps if you get stuck. All right, let's go down and look at number 3. So let's I'll jump in here. First step is what? What's my first step? Okay, so get rid of the 6. Everybody add 6. So y plus 6 equals x squared plus 8x. Second step, put in the what?
16.
Yeah, put in the blanks. So, and that is, you said was a 16, Kent? Why 16? I agree.
Divide 8 by 2 and then square it.
Okay, divide 8 by 2 and get 4. Square it and get 16. Now I know this sounds like a trivial question. What did I add really to the right side? Not a trick question. 16. So what must I do to balance it?
16.
Add 16. And I'm going to ask that same question each time. All right, so we add 16 to both sides. So here we go. Y plus 22 equals, who can help me with that parentheses? Marissa?
X plus 4 squared.
X plus 4, the quantity squared. Does anyone have a question where she got the plus 4 from? Let's review the plus. The plus comes from where? The plus 8. That's where the plus comes from. And Greg, the 16 comes from the square root of 16 is 4, or you want to think of it as half of 8. Either one works. My final step is what? Isolate the y. Minus how much? 22. Wow. What's my vertex? Negative 22. Good. What's my y-intercept? 0, comma, negative 6. So we go all the way, remember, back up to here for our negative 6. All right, so let's do some sketch. And yes, I realize this is negative 22. That is intentional. So negative 4, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And I'm doing this intentionally, and my goal is to show you a bigger, zoomed out picture of what a parabola could and might be. Aaron?
If you forget to switch like 4 as a negative 4, would it just reverse?
The parabola will end up being on the other side of the y-axis. It will still look the same, but it will have been shifted to the other side of the y-axis.
Why do you have to change it? Like, what does that mean?
Well, when we put a positive 4 in there, it would be 4 plus 4 is 8, and we don't want 8, we want 0. So when we put a negative 4 in, we get negative 4 plus 4, which is 0. So it has to make a 0. That's all. All right, what other point do I know? I know my green point, 0, negative 6. So I'm going to put that one on there. Here's my green point. How far is the green point from my axis of symmetry? How far is the green point away? Right here. It's 4 units, so jump 4 units over here. And we have a basic shape. I need a little bit more form. Is my A value 1? Yes. So it's going to follow our pattern. So here we go. Over 1, up 1. You have to kind of estimate a little bit. Over 2, up 4. Over 3, up 9. But the last one is kind of neat. Over 4, up how far? 16. And let's count. How far is it from negative 22 to negative 6? It's 16. And so the neat part about this is point is really over 4, up 16. And so it follows that pattern of squares. Marissa?
Like, are we allowed to do it like with evens or like go by 5 increments that it would fit on the graph?
Well, you can. What's going to happen is your graph is not going to necessarily, though, have the same shape as a real graph with that form.
Okay.
And my goal here is to show you, look at this graph from a large scale perspective. This graph is not flaring out. Which way is it generally going? It's shooting where? Up. And that's what a parabola does. It does not get really wide. It shoots up drastically. From this point was up 16. The next point would be over 5, up 25. And so right up above here, to be honest, you have to go a whole nother up to all the way to 25 before you cross over into the next line. So you don't want to take your graphs and make them start to drift outwards as a graph. Okay? So Marissa, I would really rather you try to be as consistent as possible with your graphs. I'm looking for your graphs to be a fairly accurate sketch, not just a general swoop and be done. So a very accurate sketch. But our big goal is right here. Vertex form. That is our most important piece that we're looking to do today. Find vertex form. Find H and K. All right. Now, come on down here to number 4. On number 4 and number 5, I've added our last tiny piece. And all I've added on number 5, if you notice, is the 2. And on number 4, I added a negative 1. So, what I want to do first is just what we've always done, is subtract the 3. So y minus 3 equals negative x squared plus 2x. If you remember back to our original instructions, in red, the second instruction said... Yes, sorry. Thank you. Our instruction said, if there is an a value, factor it out. Now in this one, we finally have an a value we can factor out. What's the number in front of the x squared? It's really a minus 1. It's not really neat there, sorry. It's really a minus 1. So what we're going to do is we're going to factor out that minus 1. What's left when we factor it out? X plus 2x. X squared plus 2x. I factored out the negative 1. And this is similar. You know already, Greg, our parabola is now going to go down. That's the indication of that negative 1. And at this point, the negative 1 is done. We're over with it. And the reason I had to factor it out is I had to get my x squared to be positive. Because my x squared always needs to be positive. And now we're going to go and do the problem just like normal. Y minus 3 plus blank equals negative 1, parentheses, x squared plus 2x plus blank. Now pause for questions. Karen.
How did you get plus 2x?
Because negative 1, good question, let me highlight it. Negative 1 times plus 2x is negative 2x. It has to, negative 1 times what is negative 2x? This has to work here to get my reverse there. I'm factoring out a negative 1. Aaron.
Wait, so are you just putting parentheses around that? Like, are you just separating the 1 and the x?
Yeah. Yeah.
Can you do that for like the one on example 5?
We're going to, except we're going to take out the 2. We'll get to it. It'll make sense. What's half of 2?
1.
Squared. So everyone add 1 here. Now, freeze for a second. I'm asking the same question every single time. What am I really adding to the right side? What am I really adding to the right side? Am I adding 1? No. I'm adding negative 1. Because you have a negative 1 times 1. That's what I'm really adding. I'm really adding a negative 1. And so you really have to counterbalance that by adding a negative 1 to the other side. And that's the only issue when you have an a value, Tom, is it's just you have to pay attention. What am I really adding to that?
Did you say the lines have to be the same number though?
It is.
You're blank.
What's negative 1 times 1? It is a negative 1. We just have disguised it with the factoring. That's all. So we're really adding a negative 1 times 1, which is negative 1.
Why don't we just write negative 1?
Well, we did right here.
No, on the other side.
Because we can't, because it's inside the parentheses. So on this side, this becomes y minus 4. On the other side, this becomes negative 1 times parentheses x plus 1 squared. I'm going to get rid of that little line there. It's a little confusing. Once again, the plus on the 2x leads to the plus on the 1.
Wait, why can't we just get rid of the number 1 0 and multiply it?
Well, we can't just drop it. It's still there.
We used it.
This one right here?
Yeah.
Well, you can't just drop a number. You have to continue to bring it along whatever its impact is on the next problem. And so our final answer is negative 1 x plus 1 squared plus 4. And this looks like our problems yesterday. The only difference now is we know our parabola, instead of opening up, Kent, is going to open down. Right? So let's identify our vertex. What's my vertex again?
Negative 1 4.
Negative 1 4. What is my y-intercept? 0 3. So let's plot these. Negative 1 4 0 3.
You can go down, over 1, down 1, right?
Yeah, that's right. I went over 1, down 1. My next step is going to be over 2, down how far? 4. Over 2, down 4. So that was over 2, down 4. What's my next point?
Down 3 and 9.
Over 3, down 9. So that was over 3, down 9. And I can't go down 16 because it's off the graph. So let's sketch.
So when you're finding your vertex and intercept, the negative 1 means nothing.
Exactly. The negative 1 only has to do with which direction the graph is going to open or close. So, and you know negatives mean the graphs go down, and positives. That's why I can't drop that negative. Because if I drop that negative, Danielle, the graph all of a sudden, instead of opening down, would open up. So I have to just kind of drag it along to each step. All right. Let's look at our last one. First step is subtract 10. So 2x squared plus 8x. I'd like to get rid of that 2. So parentheses it. So x squared plus 4x. Fancy word, you can say factor it out. All right, y minus 10 plus blank equals 2 x squared plus 4x plus blank.
Wait, if you make it 4x on that one, why not in example 4 do you make it 2?
Okay, remember the 4x is gotten because 2 times 4. That's why it's 8. You with me?
Yeah.
So up here, Aaron, if you look, negative 1 times positive 2 is the negative 2 up here.
Oh.
So it's just the distributing. All right, what's half of the 4x? 2x. And what's 2 squared? 4. So put a plus 4 in that blank. Am I really adding 4?
No.
No. Mike, what am I really adding? Yeah. Wow, Mike, your ventriloquism skills are tremendous, I have to say. I'm really adding 8. Because I'm really adding 2 times 4. That's what I'm really adding. So let's simplify now. Y minus 2. What goes in my parentheses?
X and 2.
X and 2. So x and 2. How do I know it's a plus?
Wait, how'd you get that?
The x plus 2?
Yeah.
The square root of 4. It's always the square root of the back number.
No, how'd you get the number?
How did I get
I
what?
thought it was half of the 4x.
It is. It's also half of the 4x.
So you can use either one?
Yeah, that's the beauty. Let me flip back. Okay? Let's flip back. Half of 6 is 3, square root of 9 is 3. Okay? Hold on. Half of 2 is 1, square root of 1 is 1. Half of 8 is 4, square root of 16 is 4. Half of 2 is 1, square root of 1 is 1.
Okay.
Starting to click?
Yeah.
Okay? So, half of 4 is 2, square root of 4 is 2. And that's why I say sometimes it helps to do multiple examples here. So my answer is 2, parentheses, x plus 2 squared, and then the minus 2 comes over as a plus 2. So let's write, what is my vertex? Someone other than over here, let's kind of get far side. Henry or Sean, what's my vertex? Remember, HK. Yeah, there you go. And what is my y-intercept, Henry? Your turn. Go up to the original problem.
0, 10.
0, 10. So let's plot those. Negative 2, 2. 0, 10. Draw your axis of symmetry. And this is one is kind of our fun one at the end. Everybody get there, and then we'll plot some points to finish this out. Our normal pattern is 1, 1, 2, 4. That's when A equals 1. But what does A equal in this case? A equals 2. So the normal pattern, Cole, instead of going over 1, up 1, we stretch it vertically by 2. So over 1, up 2. So go over 1 and go up 2 right to there. I'm going to put over 1, up 2, because we multiplied by the A value. Whatever the A value is, we multiply it. Over 1, up 2. To get the next point, I normally would go over 2, up 4.
Over 2, up 8.
Exactly, Sarah. Over 2, up 8. So I'm going to put a little note to there. Over 2, up 8. And once again, the reason it's up 8 is that normal up 4 multiplied by 2. So let's reflect that. And now we're certainly have enough points. So we can do a sketch. And there we go. Questions? Aaron?
So, don't you say that you have to take the half of the linear term and then square it for the blanks? This doesn't.
Okay, let's go back through all 5 and talk about half of the linear term square. Let's go back to the first one. The linear term is 6x. What's half of 6? Square it. There's your 9.
Yeah. So
Okay, let's go to the next one. The linear term, I'm going to highlight it, is negative 2. What's half of negative 2? Negative 1. Squared. There's the red plus 1. Okay, let's go to the next one. Linear term is 8. What's half of 8? Square it. Okay. Let's go to the next one. Linear term is 2x, half of 2x.
Don't you take the linear term from the original?
No, you take it from right here. What's inside the parentheses? So half of the 2x is 1. Squared is 1. And our last one, our linear term is here in the parentheses. Half of 4 is 2. 2 squared is 4. So the nice thing is after we've done 4 or 5 problems, we can start to see the patterns of our different pieces. And that's why sometimes it's good just to kind of roll with the examples at the beginning, and then about the third example, it tends to start to click.